Hi, my name is Eric and welcome to our very first ROXY tutorial video. In this video I will guide you through making a simple pick and place runtime such as shown here and help you get familiar with the ROXY editor and joystick. Alright, let's jump in. Before we can get started on making our runtime, there are some prerequisites. First of all, you need to make sure all relevant devices have been added to ROXY's device list. How to add devices and install the ROXY driver on a robot will be explained in another video. A link will be provided in the description. As you can see, I have already added the Staubli RX160 to my device list, so we can continue with making our runtime. Go back to the start page. At the start page, you can use the three buttons below to access the documentation, add a device such as a robot, or create a new runtime. Press the Add Runtime button. This will move us to the runtime editor, and a prompt will ask us what kind of runtime we want to make. Here you can select a template for stacking or unstacking objects, but since we will be making a simple pick and place runtime, we select Start from Scratch. This will open up an empty editor canvas. This is the place where we will build our runtime by adding commands such as moving the robot and using the gripper. But before we start building this, we will need to obtain the pick position where the robot will go to grab the item. To control the robot, we click Control in the top right of the canvas. The pop-up window asks us which device we want to control. If you have multiple robots in your device list, you can select which robot to control. Since we have only one robot, the correct device is automatically selected, so we can go ahead and click Open. This will cause ROXY to open the joystick. Now that ROXY is connected to the robot, we can start moving it. In this tab, we can move the robot in the X, Y, and Z direction with the use of these two thumbsticks. Now first what I will do is move the robot closer to the box position, starting by moving it down with the use of the right thumbstick by pulling the thumbstick down and releasing it when I think it's close enough. Now I move it a bit up, a bit to the right, and a little bit lower. This looks about close enough. Now that I am close to the object, I want to do some fine-tuning. To do this, we can switch the tab to Manual Input. Here we can see the current position of the robot and change it with a much higher precision. I want to move the robot a little bit closer to the center of the object. Now I know that this is a negative in the Y-axis of the robot, but if you're not sure in which direction the robot will move, I suggest you start off with a small step and observe which direction the robot is moving. Now I want to move the robot 5 centimeters towards me, and therefore I will subtract 50 millimeters from the Y value and click Go to Position. Alright, that might have been a bit too far, let's move it back a bit. Also, I always like to have round numbers. Let's set it to -1280. That seems fine. Now let's move on to the X-axis. Let's start by adding 2 centimeters and see if that's good enough. I'll round it up to an even 430. This position looks quite good. If we wanted, we could have moved the robot with a much higher precision, but this is good enough for now. Now let's move the robot down so that it touches the box. I will start off with -730. Alright, at least 2 more centimeters, I guess. Okay. A notification that sometimes pops up when a large movement could be occurring. This is not the case in this situation, so I will press OK. Almost the right position, but I would like the robot to push a bit more onto the object, so let's go down 5 more millimeters. Alright, this position looks good. Now let's send this position to the editor canvas so that we can use it to move the robot back to this position whenever we want to. To do this, we go to the Save Position menu in the top right. This gives us a couple of options. If we choose coordinate block, a block will be sent to the editor canvas where the current position in X, Y, Z, including rotations, is filled in. The joint block puts a block in the editor canvas where all 6 individual joints will be filled in. The reason there is a difference is because a robot can get to the same coordinate and rotation with different joint configurations. For the purpose of this video, I will only be using coordinate blocks, so we'll click on that. Now you can see that one block has been added to the canvas. Now that we have defined our pick position, we should also have an approach position where the robot moves to before going to the final pick position. I'm going to make the approach position 20 centimeters above the current position. Again, we get the warning telling us that we're going to make a large movement, this time correctly, but I know that this is a safe move, so I'll press OK again. Again, we go to the Save Position menu and click Coordinate Block. We can see that we now have 2 blocks added to the canvas. Now that we have our pick position and an approach position, let's go back to the editor. We can now see the 2 blocks that have been added to our canvas. Position 1 is our pick location and position 2 is the approach location. You can also see and modify any of the values of the position if you aren't satisfied with the current values. To keep things a bit organized, I like to rename the positions to something I can understand. Location 1 was our pick location, so let's call it that. Location 2 was the approach location, so we'll call it approach pick location. The next step is determining the place position. The easiest way to do that is to pick up the object that we want to place. To do so, we go back to the joystick and go back to manual input. Now request the robot current position by pressing Get Position. Since we only moved the robot up 20 centimeters to get to the approach position, we simply go back to the pick position, which was at a Z value of -755. This is again a large but safe move, so we click OK again. Now to pick up the object, we go to Quick Action on the top bar. In here we have a couple of options, such as Go to Home and Go to Rest. Explanations can be found in the documentation. For now we are only interested in the command Close and Open Gripper. To pick up an object, press Close Gripper. This will activate the valve and grab onto the box. Now to lift up the box, we go back up to the approach position. Now that we've picked up our object, we can go ahead and teach the place positions. First, let's go back to the Coordinates tab to move the robot roughly to the place position. Alright, once we've reached a position that's acceptable, we go back again to the Manual Input tab. First, I'll move the robot down to -750 in the Z-axis. Now to move a little bit closer to the edge, let's subtract a few millimeters from the X-axis. Maybe a bit more. Maybe a bit more. Something like that. There's still some room left to go lower, so let's lower our Z value to -755. A bit more. Okay, this looks good. I think this will be our final place position. Let's save this to the editor. So save position, coordinate block, and now we go for the approach position. Just as we did with the pick position, we'll go 20 centimeters up for the approach position of the place position. Okay, also save this position to the canvas. Now we have all our positions, so we can move back to the editor. Now you can see 2 more locations added to the editor. For clarity, we'll also rename these locations. Location 1 was our place location, so let's call it that. And location 2 was our approach position, so call that approach place location. Alright, now that we have all the required locations, we can get rid of the robot for now and focus on the editor to make our complete runtime. On our canvas, we're going to build the runtime we're going to run, which is pretty much the logic we're going to build. On the left, we have all the block categories, categorized by function. First, we have robots. In here, all the blocks regarding the control of the robot can be found, such as the basic robot goTo function, which moves the robot to a target location. We will mainly be using this block today. The next category is locations, where all the blocks regarding positions are located, such as location and joint positions. Then we have jobs, with some pre-programmed logic blocks. Signals controls different types of devices and runtimes. Logic is a category where more complex functionality can be found, such as an if-else block. The flow category consists of blocks that control the flow of the program. The pelletizer category has all the blocks that are related to the pelletizer. and the settings category, which consists of blocks that can be used to set specific settings such as the speed of a robot. Now, as we said before, we will be mainly using the robot go-to block, so let's grab that from the menu by drag and dropping the block onto the canvas. Let's create some space by dragging inside the canvas. So first we want the robot to go to the approach pick position, so simply drag the approach pick location to the robot go-to block. Notice when I release it, it snaps onto the go-to block. Now we need another go-to block and attach the pick location to it. Now let me just drag the location blocks a bit down so we have a little more space to build our program. Once the robot has reached the pick location, it needs to pick up the object. So let's add a pickup block from the robots category and place it under the go to pick location block. After picking up the object, we want to move back up to the approach position. So let's grab another go to block. Now we want the same location as the approach position block, and to duplicate the block, simply select it and use the Ctrl+C and Ctrl+V combinations to copy and paste the selected blocks. You could also right-click and click Duplicate. We can now connect our duplicated block to the go-to block. So after picking up the object and lifting it up, we want to move it to the approach place location. So another go-to block and attach the approach place location. Then one more to go to the final place location. After reaching the place location, we want to release the object. So let's find the release object block under the robots category and drag it under the place location. Now let's end our program by moving the robot back to the approach position, so one more robot go-to block and copy and paste the approach place location. Now that we have built our runtime, we need to tell the blocks which robot to control. So click on the drop-down menu of a block. This will show all robots which you can control. Since we only have one, we only see the RX-160, but if we have more robots, we would see them here. We select the RX-160. Now we could do this for each individual block, but we could also let ROXY fill the rest automatically. That option is under the File menu. The Edit menu. Here we click Fill Automatically. As you can see, all the empty fields are now filled in with the RX-160, and ROXY also notifies you to check the runtime just to be safe. Now we are almost done, we only need to give the runtime a name. We can do that in the top left by clicking Edit Name. We delete New Runtime and call our runtime Simple Pick and Place. Let's first save it. Under File we have the option Save Runtime. Now that we've saved the runtime, we can hit Run. By pressing Run, ROXY automatically saves the runtime again, but since we just saved it, ROXY informs us that we will overwrite the already saved runtime. This is just an extra safety step to prevent you from accidentally overwriting a different runtime. We simply press OK. Now ROXY will try to connect with all the devices in the runtime, so let's bring the robot back. When ROXY is ready, it asks us if we really want to start the runtime. So we hit OK, and then we can see that all the blocks are executed and the robot moves to the pick location. He picks up the object, moves to the approach place location, to the place position, releases the object and back to the approach place position. And with that, we've made a very simple pick and place runtime. Thank you for watching our tutorial video. Good luck building your own runtimes.